Alrighty, I believe I'm recording. What's going on, everybody? Yesterday I did a really short video because I was really tired, but uh, jeez, yeah, I was really tired, and I forgot that I had to do a video today. Uh, so again, thank you guys hella for the support. So I'll switch my screen here for you guys to see. 64 subscribers. You guys been commenting and helping me out and stuff. So it means a lot to me. Yeah. So if this is your first time in the channel, nice to meet you. I'm Marty. Yeah. So today, yesterday I did some LeetCode problem I didn't even finish, and today I finished this stack problem on my own. Took me an hour, but kind of lost right now because I'm kind of breezing through these like stacks, and like if I keep breezing through these stuff, I'm not really understanding the problems, if that makes sense. Like I gotta do more examples to solidify my knowledge in my head. So some things that I wanted to do was come back to the exponential sorting algorithm. It was sorting algorithm. So what I was thinking today is to understand one more time. I understand bubble sort, right? I understand bubble sort, how it works. So what bubble sort does is it checks the first, like say there's a list, it checks the first index with the second index and then switches them if it's less than. So let me explain this code so I can understand it as well. Dang, man, you guys can barely see me. It's insane. I wish I had should I have my flash on my phone in my face or something? Yeah, it's way better. I need to invest in a ring light or whatever those are things called. So if I turn this up, is that better, man? I have no clue. So I guess I'll just leave it like this. So what this is doing is so swapping goes true. We're just saying swapping is true in the beginning. The end is the length of the array, and then while swapping equals true, so the while loop is continuing. Swapping equals false if this for loop stops. So for I in range, the second element in the second element in the array, if nums I, which is the first element, the element before, if it's greater than nums, then we say swapping it continues to be true. Then nums, the left element and the right element swap, and then we continue doing that until this isn't true, and then yeah, okay, so that makes sense. So bubble sort done. Merge sort. Merge sort looks a little bit confusing. I don't like the light brown. Okay, merge sort. What I basically remember, merge sort, it gets half and half. So yeah, like divide and conquer, whatever it's called. So we know if the length of the array is less than 2, then just return the array because it's already sorted. So after, we'll do half. So half is the len nums. Okay, so the length of nums you can say is 10. Alright, 2 is because it's gonna be 5. So that's the half. So the first half is gonna be everything nums is start stop. Oh, this is stop right here, right? We start here and everything to end. We do everything to end and we stop at the half. Makes sense. So first half that, second half that. So the left sorted side sorted array is the merge sort first half. So left sorted is merge sort. We're calling it recursively recursive, whatever, I forgot what it's called, first half, and the second half. Then we return and we merge the first half with the second half. Well, we're calling this and we're combining them together. Okay, so what merge does is final is the final list together. I is just the starting index. Those are the indexes. So while I is less than the length first, oh, okay. First is what again? Inputs A and B are two sorted lists of integers. Oh, so this is the first half and the second half. Okay, if I is less than the first half, then J is less than the second half. If first I, so if first, the list in first, it's not the list in first, this is the numbers. Input A. Confused right here. First append the first I plus 1. Okay. Alright, I think I understand this. And then merge sort and then insertion sort is when
First, let me talk about when it has a neat is small enough track of two indexes, I and J. I will be the index of the current number that we are on, and J will start at that same position, but it'll act I and J equal to position 1 or index 1, which is of course the second position. Now the number doing the swapping will be the number at J and the number at 1 less than J. I actually has nothing to do with the swapping. It's just kind of keeping our place in the algorithm.
oh, and then that moves forward. Yeah, I remember this. So what this does is it checks I plus 1 until I is at the end. That means it's sorted. So it checks J minus 1. If J minus 1 is less than J, swap. So that doesn't work. We go to the next one.
Algorithm. So we look at the number at position J, at the number at position J minus 1. And if they're out of order, we're going to swap them and decrement J. If they're already in order, then we can just move on and increment I. And whenever we increment I, we also move J back up to where I is. It seems really fast at first because I and J are close to the start of the list, so the amount of backtracking J has to do isn't very much. But you'll notice as
I get it. Okay, insertion sort, quick sort. Quick sort was when it
Quicksort is fast and efficient. It's a pivot number, and to keep things simple, we'll just arbitrarily use the element at the end of the list. In this case, 5. Next, we need 2 pointers, I and J, to keep track of things as we're going to be swapping them around. I will start at index -1, which of course isn't a real index, but we need to be able to increment into index 0 on the first swap. Then J will start at index 0, which is 8. So in this case, we'll be comparing 8 and 5. And because 8 is not less than 5, meaning J is not less than the pivot, we don't move I, but we do increment J. Now we do it again.
okay, I get it. Okay. So now that I learned stack, stack, in neat code, is there neat code? We have some stack problems here. Okay. Fuck it, why not? Should we? Okay, let's understand this problem first before we go into stack. So stack. Okay, what stack is? Stack is a. Wait, I'm kind of. I want to see what problems we have. Heap trees, binary search. Okay. Where were we? Holy moly, stack. Do we go to 2-pointers as well in this course? Queues, hash maps. No. Okay, let's try this problem out. So I know I get it. So this would be true. I literally did a problem just like this right now. Kind of like how this is saying it. So okay, let's understand stack again. So the way stack works is stack is kind of like a list, but it has some type of parameters around it. So it's called a stack because it behaves just like a stack of physical items. Imagine a stack of plates. It's easy to take an item off the top of the stack, but you can't really get to the items in the middle or the bottom without removing the items on the top. You'll often hear a stack referred as litho. Right.
New computer science students really overthink stacks. They're just about the easiest data structure to learn though, so honestly don't stress about it. Imagine you're at a salad bar, but before you load up on bacon bits and croutons, you need a plate. Now, it's a self-serve situation, and you notice a giant stack of plates sitting on the counter. Do you grab one from the bottom? The middle? No, because you're not a complete idiot. You grab one off the top of the stack. Okay, but here's the thing. You're with your romantic partner, who you're out to dinner with, and they explain they have to leave, and you decide you just don't even want salad anymore. So do you lift the giant stack of plates and shove your plate back at the bottom? Stuff it into the middle? Again, no, you're actually a sane human being, so you just set the plate back on top of the stack. And that's it. That's how stack data structures work. You put items onto the top of the stack, one at a time, and then you remove them off the top again, one at a time. Once something has been pushed down to the very bottom of the stack, you actually have to take everything else off the top before you can get down to it. Stacks are last in, first out, LIFO. That makes them restrictive, but useful in specific situations where you're okay with that limitation. For example, undo or redo in a word processor, or the back button.
There's something that I'm confused about. Last in, first out. Last in, first out, storage. 1, 2, 3, 4. Oh, last in, first out. First in, first out. Oh, we're doing this one. Last in, first out, last in, first out.
With Monday.com's intuitive work management platform, you have the power, not IT, not...
LIFO, or the last in, first out method to value inventory, assumes that the last units into the store are the first units sold. For instance, if a store had the following purchases of folding chairs into inventory, which total 95, and 4 chairs are sold, these 4 chairs would be assumed to be from the chairs at a cost of $12 per unit, of 1,500. The number of units sold. The beginning inventory.
Brother, is this finance? Like, what the fuck?
FIFO is a queue, LIFO is a stack. LES, short answer. FIFO stands for first in, first out, and LIFO stands for last in, first out. There are 2 interfaces in the JDK to model these. Queue, that models a FIFO, that is extended by DEC, and that's the second interface that models a LIFO. The current link.
Fuck, we gotta learn German now.
in your browser history. Those are real world examples that actually won.
You'd be right. A stack is a list with fewer features. But that, you guys hear me? But that, you might be wondering, you'd be right, stack, by restricting the ways we interact with data, we guarantee that certain operations are building with last. Here are all the operations a typical stack supports along with their big old time. So push is all one, pop, peak size. It's all one. Let's see if stack late code okay, I think it's getting to it.
At Shock, we're dedicated to defending childhood and ensuring our patients experience joy and play, even in
Welcome to LeetCode Python Coding. That is a working title. I'll think of something, but all stacks. So what is a stack? Well, I think the easiest way to conceptualize a stack is like a Pringles box.
What is this?
Stack is a linear data structure where we append different objects in order, but whenever we want to delete or take a peek at what's at the very top, it's going to be a last in, first out sort of structure. So essentially, if we had this Pringles box metaphor, if we want to add an object, it would get to the very bottom here. So say that we added one, it would get put down right here. Let's say that we put down another one, put down two, gets added here. But if we want to pop it off, then we take off the last one that we just added. So 2 would get popped off. And let's say we add another one. This one would be 3. This will continue in this order. So essentially, like, these data structures could be useful for certain situations, like maybe the undo function, where it records the very last action that you did. And if you want to undo it, it's going to pop off that very last action here. And the neat thing about stack is it popping off is going to be O of 1 time complexity. So simple enough, right? It's a pretty easy data structure to conceptualize. But in LeetCode, essentially the basic pattern that you'll be seeing is it's something like you initialize a stack, and for everything inside of the object, for something in objects, there's going to be some sort of condition. And there's obviously it's not going to ever be this simple, but there'll either be a while or if condition, and we'll probably pop off something off the stack and usually add something to the stack here. Now I should add one thing usually is here we do some sort of check with that very top item on our stack. So it'd be something like stack -1, and we do something here with usually this object. Now this isn't always the case, but I think it's a good kind of pattern.
Oh shoot, this guy's solving the valid parentheses stuff. Oh damn, yeah, he's actually solving the problems. Okay, so yeah, I understand it now. I understand what stacks are. That video kind of like reading this and then doing that is like fake. Like I don't like kind of get it, but yeah. Okay, let's see if I can try to solve this problem. It's very similar to the one I just solved. So does this import? I'm so curious. No, it doesn't. So stack. So do I do a list here? So for a character and input string, if character is this, stack push. Okay. So the way this works is for character and input string, right? For character, if character is equal to this, we're pushing. Explain this code bar line for line and make sure I understand everything, as well as do a example using this code so I can see how it works. Sure, let's break down the code line by line so you fully understand. Here's the code. Right. Line by line, from stack. So this line imports a custom stack class. So the stack class likely has methods push, pop, and peek. Can I do this here? I don't flippin' know. So this defines a function called isBalance. It takes a string input string as input. The string will contain characters, especially parentheses, right? So here you create an empty stack to help you track opening parentheses, right? Think of a stack like a vertical tray holder. You push trays in and pop the tray out. Okay. Trying to envision it. For characters, so this loops each character input string. So for example, if this, it would do, yeah, that's exactly what I was doing. So if character is this, if the current character is open parentheses, it gets pushed into the stack. It adds on top of the stack. If the current character is a closing parentheses, then we try to match it with the most recent one on the stack. If stack is none, if the stack is empty, example, no this to match this, then pop returns none. Just pop is none. If pop is none, return false. So if the size of function returns it, this means it's unbalanced. There's a closing. There's a closing and it's not pause. I need to visually see like return false. If we couldn't pop the parentheses are unbalanced, return stack.peek is none. As we go through the whole string, we check if the stack is empty. If there are leftover stack, then it's also unbalanced. If it's all empty, we return true. Example to this. See, this is what I need. So push stack. Because what I understand understand is when what I understand is that 4-character input string is when we get the character in the string, we push it onto the stack, and then what? I'm confused. So the first one is this. Loop there at 1. So we push. Stack before we push. So we're gonna stack after we do that. 3. Pop match. Oh. Oh. So we push this. Pop match and remove. Oh, it pop. I see. We have another one of these pops, so now the list is empty, and the loop. This returns true. Returns. That's true. Holy shit. Okay. I get it. I get it. The thing is, push it. So, if stack. Oh, I get it, man. I get it. Holy shit, I get it. So the way it works is so if the character is this, we're gonna push this into the stack. Right. So if the next character is this, we're gonna remove the one that we just put into the stack, and now it's empty. So say it's uneven and there's an extra one of these. Then if stack is none. Okay, how does it return false? Okay, I get the true though. I get the true. Example. Oh yeah, this is good. So say we put this into there, we push there into there, and then we push this another one. We have this pop match. So we match, but it has this, and now it still has this. It returns false. How does that code work? So returns it. Oh, I get it. Holy moly. Dude, you guys don't understand it. For an hour, I was like, bro, how does this shit working? Like, but I get it. Wow. Okay, this is gonna be the same thing, but a little bit trickier. True. How is this false? Is not closed in the correct order. Okay, so the way this would work. The way this would work is a bit different than just the parentheses. The issue is with the parentheses is that this will be fine, this will be fine, but this will return true based off of what I'm thinking is because if it has this removed, this will be empty, this will return true. But the thing is that the brackets are not closed in correct order. Now this is an issue. The brackets are not closed in correct order. Of course we're using stack, so Alright, the hints are saying I don't want to look at the hints. Okay, what I'm thinking is, let's just do it and see if we don't understand. So the way we do is stack. So then we need to get four for B, for bracket, whatever, for B in S. I don't like that. For character in S. Let's just print character, see if everything's running. So you dash want me just to use a list? Okay. Yeah, this has no autofill, bro. Oh, it has to be a boolean? Fuck, I want to see if this is working. Dick. Whatever, just keep going. For character and S, we're getting each one. So if character is equal to this, or we're doing these brackets as well, right? Yep, and then the squiggly ones, or if that is true, if character is equal to we would like to remember and we would like to. Well, can I append it? Do I have to append? Obviously, the pop push shit only works when I'm using a stack. Obviously, it was not going to be a stack if I use a pen. I would have to use push. And we're learning stacks. Okay, that's what I'm going to do. I'm going to just do something first. So we're going to do a stack, append the character. And then, okay. Control, copy. Do not show me any code or answers. I would like to know if what I am doing is in the right direction. Say, baby. Goodbye. 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 You're very close and over, but there's one issue: is the if condition. You're using stack to keep track of open brackets. You're looping through each character in the string S. You're checking the character's open bracket by pushing the stack. Perfect idea. What's going on? The logic doesn't work the way you think it does. It always evaluates the truth because how Python handles the OR expression. But you said not to give you the code, so I won't tell you how to fix it. Just know the condition is not correctly checking if character is one of. Yeah. Instead of returning true or false, you accidentally return a list because the logic doesn't fill properly. That's why the error says your output with the expected return. No, dick. That's not what I meant. This is not, no. Okay, it's gonna give me an error because of this. A character is equal to that. Yeah, why I put is? If a character is equal to that. Yeah, I'm supposed to return a boolean. If stack if brother, you know what? This is why I like using this, so I can see what the fuck is going on. I don't understand if I'm doing right, bro. Please, no advertisements, bro. I ain't got time for that shit. So, print. Whoa, that's not what I meant. And the indentation is wrong. this is the logic I have so far. But this is the issue with the condition. The line doesn't work the way why it's broken visually without giving you the fixed code yet. Python evaluates parentheses or bracket order first, which just becomes parentheses because in an OR chain. Okay, shut the fuck up. Let me just try this on my own. Boom. So now we have that. If character is equal, if character is equal to the same shit here, right, but the opposite way, so I would have to do this, that, this, that, this or that. We gotta see if the length, no, if it's empty, it returns false, right? See, if it's empty, yeah, if stack pop, yeah, pop removes. It's a pop. So pop is not if. That's wrong. It should be right here. We're gonna do elif is that if stack dot pop is none, we're gonna return false. Else we're gonna do, whoa, that's wrong. Else we're gonna do the stack pop, yeah, if stack pop is none, return false. Else no, we don't need that. We're just gonna return stack. We're gonna return stack pop. What the fuck is peak? Oh, if holy shit, I didn't mean that. It's not double equals, bro. Oh, if it's empty. So if the len of stack is equal to 0, return true. Just to see if it'll run. It's gonna throw an error if I submit. I already know. Yeah. Character in. Why does it give nothing? Oh. Why did it do that? Is this the right side? No, it should be that side. It should work. Yes. Fuck, bro. I don't get the fucking issue. And you pop from the stack. I don't know how to match. So that's the issue. I need to check when the pop stack is correct. So that means this. I actually don't even have one clue in my head how to check if it's the same type. Oh, that is smart. A dictionary. Fucking dictionary. So if fuck would I do? Damn. My thinking, like my IQ is slow. Really. This is insane. Does it equal the, yeah. So if it's a dictionary, if is the bracket if pairs, so the keys for pairs is pairs key, if pairs, so that bracket car and right P, if car and right P, if the car and right P then we pop. Oh, fuck, I'm kind of confused. Right. If character is in closing bracket, if stack is empty, return false. If stack does not equal, holy shit, if it does not equal, if stack dot pop, yeah, holy shit, if the stack dot pop if stack dot pop no, I'm doing something wrong. If stack dot pop is equal to none, we return false. If stack dot pop does not equal the pair's key, so this, if the stack dot pop does not equal the key, that returns none. Man, that's so smart, bro. How did I not think of that? Holy shit, bro, I did not mean to. The pairs and the key would be the character. I have an issue. If the key does not equal, if stack pop, if stack pop does not equal, if the stack is empty, if character is a closing bracket, right P, if it's a closing bracket, let me do. I think it should be Elif, huh? The thing is just, this is an issue, it's not gonna run. I'm not, before I look at this error, let's see if I know. So we know, okay, so if character in left P, we're appending that into the stack. To the stack. Elif, if character is in the right P, right. So now we're saying it's in the right P. Don't we need like a characters in right P? If the stack dot pop is equal to none. So stack dot pop does not equals the, if that character in the right P, so is the right P. It's none. Do I have to say character? That's why I put character. This is checking if the function object stack is equal to none, which will never be true. Oh yeah, that. This has to work because I'm not doing stack.pop. Fuck. What if I do stack.pop again? We can't call it twice. Yeah, that's the issue. I don't get it. What's wrong with the second one? What's wrong with the second one? First check this. No, then do this. The pop is not. That's stupid as fuck. What? I have to call another pop? That's insane. I don't think that's stupid. If not stack. Bro, I don't know how to fuck this, like... This gets me annoyed because I don't. There's no way I would have known that. Like, how am I supposed to know that? And now they're saying that I gotta do this. Like, what? I gotta call it again. And, bro, why you gotta do that, bro? Oh my gosh. Bro, what the fuck is going on, bro? I did that. I fucking did that. Tell me I didn't do that. I put above the if. I did. I did, bro. I did. No, it's not. You fucking idiot, bro. I'm gonna break my headphones. Sorry. Bro, please, 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 please give me a solution. Oh my god.
Hey
I'm
everyone.
not watching the full video. Give me a solution. Bro, move. Fuck. Bro, move. So yeah, these are this dictionary shit. That was actually very smart. Foresee. I'm very frustrated right now.
Hey everyone, welcome back and let's write some more neat code today. Today let's solve an easy problem, valid parentheses. This is such a common interview question. I think I've been asked this so many times, like in phone interviews and online assessments and stuff, so definitely a good problem to understand. We're given a string S containing only these 6 characters. They're basically parentheses type characters, right? Brackets, parentheses, closing, and there's 3 pairs, so there's an opening one and then there's a closing one, and that's true for each of the 3.
Sorry guys, hold up.
types, right? Open, and close. And our only goal is to determine if the input string is valid or not, and it's valid if the open brackets are always closed by the same type of bracket, and if the brackets are closed in the correct order. So if that's true, then it's valid and we can return true. If it's not, then we can return false. So first example, now is this valid? Well, we start with an opening parenthesis, and then we close it with a closing parenthesis. So it happened in the correct order, right? This was closed in the correct order. Every open has a matching close, so this is valid, so we can return true. Obviously, if the order was opposite like this, it would not, we would have to return false, because first of all, this opening bracket isn't being closed, right? It's never being closed. The closing needs to go on the other side of it. So we have some unclosed parentheses, and it's basically in the wrong order. Let's look at this other example. We see, okay, opening parenthesis, then it gets closed, right? Okay, now we don't have to worry about these two anymore. Opening bracket, and then it gets closed, so we don't have to worry about that anymore. Opening curly brace, and then closing curly brace, so we don't have to worry about that anymore, because they were all closed, and they were all closed in the correct order, so we can return true. What about something like this? See, we have an open parenthesis, and then we have a closing parenthesis, right? So then this is closing this one. And we have an opening bracket, and we have a closing bracket coming after it. So, right, this closes that. But this is wrong, right? This is not valid, and the reason is the order is off, right? We see that this closing parenthesis is actually being applied to this open bracket, but these do not match each other, right? So these don't cancel out. So this doesn't work. Basically, the order is wrong, and that's pretty self-explanatory by looking at it, right? It just doesn't look right. So now how can we actually determine an algorithm to be able to solve this problem? Well, one of the first things you might notice is we have to start with an opening parenthesis. We can start with this, we can start with an opening bracket, or we can start with an opening curly bracket, but we can't start with a closing parenthesis, right? Because this is never going to be valid. We can't add any more stuff over here that's ever going to make this valid, right? It's not being applied to any opening parenthesis, so we can't start with a closing parenthesis. We have to start with an opening parenthesis of any kind. And once we start with an opening parenthesis, we can pretty much add as many opening parentheses as we want, as long as we're eventually closing them, right? So if we have 4 open parentheses, we have to have 4 closing that come after it. As we add a closing parenthesis that matches, right? So these two match each other, they counteract. We can then remove them from consideration, right? We can remove them from our list, right? So now let's say we get another opening parenthesis. We see it's being applied to this one, right? And we can remove these two as well, and we can keep doing that. So remove this and this, and add one last closing parenthesis so we can remove it along with that, right? And once we're done removing that, if at the end we have an empty list, right, like this, let's say this is our list and it's empty, then we know we can return true because we closed all our opening parentheses, they matched each other, and everything went great. Also, notice how as we add closing parentheses, right, so this one, and then we have to remove from the beginning of our list, right? So now let's say we removed these, right? Now let's say we get a closing bracket. Okay, we got to remove it, and we have to remove this one. So we're always going to be removing from the end of the list, or the top of the list, or the top of the stack. So that's basically a hint for us that it's going to be helpful for us to use a stack data structure to solve this problem, because as we're closing a parenthesis, right, let's say we add this closing parenthesis, we're always going to be popping from the top. A closing parenthesis is always going to be matched to the most recent opening parenthesis. And let's say we have these 3 opening parentheses in a row. Let's say next we get this closing parenthesis. How do we know these two match each other? How do we know this closing parenthesis is able to close this one, right? How can we basically check, how do we basically match every closing parenthesis to the correct opening parenthesis, like this basically? And this closing bracket needs to match to the open bracket, and the closing curly brace needs to match to the open curly brace, right? So I hope you guys can see what I'm doing up here. This is basically going to be our hash map, actually. This is going to help us determine if a closing parenthesis matches an open parenthesis, right? Basically just the correct type, right? So let's say we had this closing parenthesis, right? We'd go up into our hash map and check, okay, this closing parenthesis matches this open parenthesis. Okay, well, what was at the top of our stack? This is at the top of our stack, right? This other closing parenthesis. So since they do match each other, we can cross them out. We can pop from the stack, right? Now let's say we get this closing parenthesis, right? Well, which one does this match to? We go up to our hash map and check, okay, it matches this one, right? This closing curly brace. Okay, let's take a look at the top of our stack. Hey, that's exactly what we needed, right? This closing is what's up here. So they do match each other. We can cross both of them out, right? And let's say lastly, we had a closing bracket. Okay, same process, check in our hash map. It matches this one. Is that what happens to be at the top of our stack? Yes, it is. So we can say these two match each other and remove them from our stack. And now let's say now we're done. Our stack is empty. We have an empty list. We have nothing left anymore. That means all the parentheses matched each other in the correct order, and we can return true now. So with that being said, let's jump into the code. And FYI, this algorithm is big O of n because we're only having to go through every input character once, right? We're just scanning through them. It is also going to take big O of n memory because we're using a stack. The stack could be up to the size of the input, which is n. So time and memory complexity is going to be big O of n in this case. Let's go to the code now. So remember, we are using a data structure, a stack, or in this case, it's just a Python list. Also, we're going to be mapping the close to open parentheses. We're going to be using a hash map to do that. So you can probably tell what I'm doing. I'm just going to take every single closing parentheses, so like this one, and I'm going to map it to the opening version of that parenthesis. And I'm going to do that for all three types. So we had the closing bracket. Let's map that to the open bracket, and closing curly brace to the opening curly brace. So these are our three pairs, 1, 2, and 3. Now let's start actually building up our stack and popping from it and just going through every character in this input string. First, let's check if this character is a closing parenthesis. So if this character is in close to open map, that means it's a closing parenthesis. And the reason why is because the keys, every key of this map is always a closing parenthesis. So if this is a closing parenthesis, we want to make sure that our stack is not empty, right? We cannot add a closing parenthesis to an empty stack, and we want to make sure that the value at the top of our stack is the matching opening parenthesis. So let's make sure. So in Python, stack of -1 is the last value that we just added in the stack. Let's make sure that that is the matching open parenthesis that we need. We can get that by taking our map and getting the character and getting the closing character from it. So we can basically, that's what we're doing. We're passing in the closing curly brace, getting the opening curly brace or whatever where we need. If these match each other, that's good. That means we can pop from our stack and then continue going. If they don't match each other, or if the stack happens to be empty, that means we have to return false, because that means our parentheses don't match, right? Obviously, we know this is not a matching parenthesis. Having just a closing parenthesis to start us off is not matching. Also, this is not matching, right? Having a closing parenthesis with an open bracket, this is not matching. So that's why we would return false. Though if we don't get a closing parenthesis, that's what this condition is for. So if we ended up getting an open parenthesis, we know the rule for having an open parenthesis is we can add as many as we want. So if we get an open parenthesis, we're just going to take that character and then append it to our stack and just keep going. So remember, at the end, once we've gone through every character, we can only return true if our stack is empty. So if not stack, then we can return true. Otherwise, we return false. So this is the solution code for this problem. I hope you understand why we're using a stack data structure and I hope that this map makes sense. This map is just a little shortcut for us, and I hope that this was helpful. If it was, please like and subscribe.
That was a little confusing, but right, for character in this. Yeah, if C is close to open, if C is a closing bracket, right, if stack and stack negative 1 close to open C, this trick should say stack is not empty, so we can safely look at the last element. The top item in the stack negative 1, matches the correct opening bracket for C. The top item matches the correct opening. If both are true, else return false. Okay. Carry stack before it. Push open bracket. Matches. Pop. Shit. It's a hard problem. It only gets worse. Curious what this is, because there's a lot of shit of it. So design a stack class that supports the push, pop, top, get, min operations. Min initializes the stack object for pushes the element val into the stack. So output null, 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 0, null, 2, 1. Min stack is a holy shit, I don't even understand this. So this will return 1. We gotta get better with stacks, because holy shit, I underestimated how hard this is gonna be. Thing is with NeetCode, bro, motherfucker, we're supposed to be doing these motherfuckers. But when the hell do I learn hash maps? Right here. It's all good. Alright. This was rough. I gotta get better. I gotta get better. Holy shit, that was hard. But okay, let's see what day it was today. Sorry guys for being so fucking, I suck, man. I gotta get better. Let me check what day it is. It's day it is day 21. So yeah, I appreciate you guys for watching this video. If you learned something new, thank you. If you learned something new, let me know in the comments. I suck, but I'll try to get better, guys. So yeah, alright, see you guys later. See you guys tomorrow.